Hi everyone. Today we're going to continue our Python programming lectures, and tomorrow we're going to continue the neuroscience. So I'll be doing both of them in this week. And so basically, last week, let's just briefly go through what we did last week. So as you recall, last week we covered basics of loops. So we had if, else, elif, and we also had while loops and for loops, and we have some homeworks about that. We also touched on random so that we can, well, bring randomness into our code. And yeah, we just covered a few examples over them. We also briefly mentioned lists last time because we iterated over them and we took specific elements from them, but it was a very surface level covering of it. In today's lecture, we're going to more properly cover what lists are, what they can do, how we use them, and how that might relate to neuroscience. And then we'll also cover some similar data structures like tuples, sets, and dictionaries. So yeah, that's mostly what we'll be doing today, and we'll just go through a couple of examples with them. Then tomorrow we're having a neuroscience lecture where we'll be covering spikes, synapses, and neurotransmitters. And yeah, I'll try to connect these two to each other. All right, first of all, can everyone hear my voice? And are there any questions from last week? Okay. Yeah, I will be monitoring the chat, so if you don't want to speak, you can type in chat. Either way is fine at any moment.
There is no questions. I'm hearing you.
Okay, good, good. Thanks. All right, then let's get to it. Share my screen. Okay, let's just open an empty file for now. So these are the examples we will go through. I will upload this file in our Discord chat. But yeah, let's start briefly. So the first theme that I want to cover more deeply is lists. So as you recall from last time, we can have something like a list of, I don't know, ages of people, let's say, 10, 15, 4, 8, 4, 4, 2, 29, 30, 15, whatever. And there are things we can do with them. Let me see. Okay. Um, uh, do I call you Alisher or do I call you Acer? How would you prefer I call you?
I'll share.
Okay.
That's right.
Yeah,
Yeah. Thank you.
sure thing. Okay, I'll keep the meeting chat here. Right. So as I was saying, we can a list is basically a collection of values. So we could have said like Nika's age is 22, someone else's age is 25, and so on. Or we can just make a list. So basically, it's just aggregating values for when we want to do similar operations on multiple of them, basically. And as before, we can print the whole list to the screen. We can print the size of the list, which is len ages. So it will just be how many elements are in there. We can print any specific element, like zero element, which prints the first, or we can do -1 to get the last one, or we can just say like 3, which will be 0, 1, 2, 3. So this one, so it will be 8. So let's see, as you can see here. And we can also print an sublist, so everything from here to here, for instance. So let's just quickly put the indexes on top of them so that we're not confused. So this is how the indexing works here. And so here, if we want to get, let's say, this sublist, we would say that we want to start at index 1 and end before index 7. So we would say ages 1 to 7, and that would give us, yeah, this sublist. So these are the main things we can do with the lists, but there's also a couple more. So let's just start introducing the things we can do with them, and then we'll basically do some tasks with them. First, we can change elements in the list. So let's say, at index 2, let's make it equal to 10. So index 2 right now is 4. And if I do this, then you can see that if I reprint the ages, we will have 10 here instead of 4 that we had before, right? What else can we do with the lists? We can also add or remove elements in the list. So let's see that as well. So you can see here, these are all the things we have here. So 10 elements. We can append whatever we want, like let's say 30. And we can also append 17. And if we then print our list again, you can see here 30 and 17 got added to the end. That's the idea. And because of that, the size will go up and so on. What else we can do with lists is that we can also remove elements from them. So let's say add element at the end. We can also remove element at the end, the last element, which is ages.pop. Let's just print ages here and then print it here as well. So if we do that, basically the last element will be removed, as you can see here. Yes. Okay, that's better. So essentially, we can do some, I guess this is visible enough, it's fine. So basically, we can access the entire list. We can access its size, and not only for printing, maybe we could put it in a variable or whatever we want. We could access a specific element, counting from top or from the other end. From other end, this is -1, this is -2, like equivalently. This index is also -1, this is -2, this is -3, and so on. Let me just because sometimes it's easier to, let me just adjust this. So sometimes it's easier to get it from the other end if you want the last or second last element. So for instance, if I say second last element is ages -2. You can see second last element here is 30, and so on. So basically you can number them upside or downside, it's fine either way. So we can do sublists. We can also change an element. We can add an element at the end or remove at the end. Now another thing we can do is we can remove first element with value of, let's say, 8. I would say ages that remove 8. One moment. So what this will do is, you can see right here, this is the list we had, and it found the first time there was an 8 and removed it. Similarly, if we were to instead say remove a 4, you can see that we had multiple 4s and only removed the first time. We could also do it multiple times, in which case both of the 4s will be removed. So those are some of the operations we can do with lists. Another thing we can do with lists, let's just briefly cover that, is insert. Insert lets us specify where we want to add an element. Like let's say we want to add at the index 3 an element by the value of 16. And let's print ages so that we can see before and after. So before this was our list, and after you can see at element 3 we got 16, and all the rest of them just pushed to the right. These are some of the things we can do. And now let's see our uses as well. Let's say we have odd numbers, 3, 7, 1, 9, 11, and even numbers of 2, 8, 4, 6, 10, whatever. We can combine these lists. We can just say odd numbers plus even numbers, and then print the numbers. As you can see, it created a list that is just combination of both of these lists. So these are the main operations that we will be using with lists. And as before, I remind you that mostly the use of lists is to go through them in a loop. Like, for example, let's say right here we have a list of numbers, right? So we could say for number in numbers, and then we could maybe print a number, or let's say square of number is a number to the power of 2. So this is bringing up to a power. So in this case, we can see this is our list, and we go through each of them one by one, and we say square of 3 is 9, 7, 49, 1, 9, 81, and so on. So these are the main things that we somewhat already touched on in the last week, but also some of it is new. So don't worry about memorizing the syntax and exact code names, just try to understand the idea. The syntax will just come from doing exercises in practice. Right now, I just want you to, basically get the idea. So these are all the main things that we need to understand about lists. Let me see if there's something more in our examples. No, that's pretty much it. Let's actually do this right now. This is a simple example. Let's just go through it. So here's what we have. By the way, we say import random because if we want to later use a random variable, we will need to basically use random libraries, either random.randint from start to end, or just random.random, which will give some value between 0 and 1. Integer between 0 and 1. Okay, let's just comment this out. So what are we doing here? Let's try to understand what's going on in this task, and then we can move on to our next topic. So we say just part 1 list deep dive. Then we say our spiking times. So what we say is, let's see at which times a neuron spiked. And spiking just means that a neuron sent an electrical signal to other neurons. Don't worry about that too much. We'll cover that tomorrow. But basically, let's say that we are checking, like, first spike happened at 10 milliseconds, the next one at 15 milliseconds, then 22, and so on. So this will be our original list. In fact, let's run this code. So you can see here, our original spikes would be this list. And then if we append just this one number, after append, this is our list. So you can see the new value was added at the bottom. We can also add a list, and there are two ways to do that. One is to say .extend new spikes, but similarly, we could say spike times equals spike times plus new spikes. This is the same thing. Or even we can just say spike times plus equals new spikes. These are same, all same. Let's rerun this. So you can see here, we had this list right here, and then we added 60.1 and 61.4 right here. And it just adds to the list. And when we say pop, we remove the last element, and we can also see what we removed. So pop actually returns the value that it deletes. So you see here in our last spikes variable, we stored whatever pop returned. And you can see right here, pop last spike 61.4. So 61.4 was the last value. We removed it, we stored it in this variable, and the list afterward looks like this. So yeah, basically just missing that one. And as we covered before, remove will just find the first time this value occurs in our list and remove it. And by the way, if you want to know what would happen if we try to remove something that we don't have, let's try that right now. Like right here. Maybe not do it, but right here, let's say print two numbers to make sure about what we have. So these are the elements we have. For instance, clearly we don't have a 5. So let's say numbers, let's remove 5, and then print numbers again. We get an error. We get a value error that says lister remove x was called when x was not in list. So if the element is not in a list and we try to remove it anyway, our code will crash. Like dangerous. One way to check whether our code crashed is to just do it like this. And so if our code doesn't crash, this should print to the screen. But as you can see, we got about to do something dangerous, and then the code crashed and nothing happened. Now we could avoid this by saying we should only do this if 5 is in the list. So we can do it by saying if 5 in numbers, then do this. This is a statement that asks, is this element in this list? So basically now, we will only remove a 5 if it's there. Otherwise, maybe just tell us there is no 5 in this list. So now, if we repeat this like 3 times, there is no harm because first time the 5. Actually, let's try with something that we do have, like with an 8. So that we see it in action. Let's move this. So you can see, oh, our list doesn't have an 8. Never mind. What does it have? Or even let's just let's do it like this. So to be clear, what we're doing here is just 3 times we are trying to remove an 8 from our list. So let's see what that will look like. You can see right here, ignore everything above that, but about to do something dangerous. Then we just removed 8 from the list because first time there was an 8 in our list right here. But then next times the 8 is not there anymore, and so we get there is no 8 in this list. In fact, let's put a breakpoint here just to make sure that we get what we're doing, and let's debug our code. So I just say debugger. And right here we can see the values of all the variables. Let's just only focus on this part. We don't care about other parts. So our numbers is list with these values. Don't worry about it, Alisher. It's fine. It's fine if you upload it in first week. Don't worry about that too much. I can still find it. So yeah, it's all right. Anyway, so let's see what happens. We say we execute this line, and so we get this printed on the screen. And now 8 is present here, so we will go inside. We will remove the 8 from our list. So you can see now it's not there anymore. And we will print on the screen that we removed 8. Then next time we check, 8 is not in the list anymore. So we'll go into the else side, and we'll just print on the screen that there is no 8. You can see here, there is no 8 in this list. So next time we check, there is again no 8. So we again come here and say there is no 8. And then if we ask for our updated list, this is the list that we get, which doesn't include an 8 anymore. These are the main building blocks of lists, you could say. And now to get into more difficult sides, let's just first explore some of the alternatives. So let's see what we have in our examples. By the way, if you get any questions, feel free to interrupt me and we can go back and maybe go through another example. So don't be shy to ask questions. In fact, I encourage you to ask questions. And yeah, I'll just give you a moment right now. is everything that we discussed so far clear? Okay. All right, then I'll continue. And yeah, just feel free to ask, or maybe if you later realize that you didn't understand something, first of all, rewatch the lecture, but if that doesn't help, insert function. Okay, yeah, let's take another example with the insert function. Like, let me just delete all of this. And let's just go through the insert function. So let's say we have names, or let's, I don't know, brain areas. Frontal lobe. Yeah, just these four. And now, right now, if I print them, it's like this. In fact, just to be clear about how inserting works, we need to understand indexes. So let me just do this. So this is index 0, 1, 2, and 3. Now let's suppose that I want to add another brain area in there as well. New brain area, let's say, which is just insula, for instance. And what we would say is, we could say append, in which case it would be added at the end. Or we could say insert at, I don't know, maybe 1, this new brain area. So right now, if I print brain areas, what do you think is the order of the new list? Like, what do you think gets printed on the screen? Can anyone write in the chat what you think will be printed on the screen now? Yeah, Anna, you're correct. Let's see it. This is what we get. Frontal lobe, then insula, then parietal lobe, and so on. So wherever the index was, this is where it gets put. So it goes right in here, and everything else moves to the right. So yeah, insula becomes the new element at index 1, and everything else stays the same. So in fact, let's print them side by side to be very clear. But yeah, like frontal lobe stayed the same, and then this one's got moved a bit so that insula could go in. That's the idea. Yeah, thanks for asking the question, because there may have been students here who were also confused and they were just not sure what to ask, or they were maybe shy. So you're helping them as well by asking. So please, I highly encourage asking questions. All right. Now let's just again briefly show other areas. So let's say cerebellum and brainstem. We can do extend, or let's just do plus equals instead. And if we do that, of course, they will be added to the end as well, like that. And if we now remove something from our brain, like let's say we remove occipital lobe, sure. If we print it again, you can see this one got removed. Yeah. So these are all the main features that we have. So brain areas, we can insert a new one, we can add a list, we can remove whatever. I guess you get the idea already. Now, just one strange thing to cover also is that technically there's no limit to what we can have a list of. So at first we knew that like variables can take different values, right? So we could have let's say all the different kinds of values. So we have text, which is some text. We can have a whole number, like 5. We can have a fraction, like 3.14. We can have statement, which is true or false. And these are the primitives, the building blocks. But after that come data structures. For instance, list, right? So we had like ages, which is list of numbers, names, which can be just whatever, list of strings, statements, which can be just a list of booleans, whatever. anything goes, right? But another interesting thing that might not be obvious at first is we can also have a list of lists. So here's an example where that might be useful. Let's say that each person has a list of favorite fruits. So let's say Nika's favorite fruits are, I don't know, banana, cherry, strawberry. And let's say, I don't know, Mari's favorite fruits are, yeah, let's just say apple, orange, grape, whatever. And Gio's favorite fruits are, yeah, let's say kiwi, mango, pineapple. If I want a list of everyone's favorite fruits, so let's say everyone's favorite fruits, I would say Nika's favorite fruits, Mari's favorite fruits, and Gio's favorite fruits as a list. And by the way, we can do it like this to make it more readable. So if I print everyone's favorite fruits on the screen now, here's what this looks like. It's a list of lists. So this is the first element, which is a list. This is the second element, which is a list, and the third element, which is also a list. So here, the first element of this list is Nika's favorite fruits. So you can see these are my favorite fruits. Gio's favorite fruits would be indexes 2, and so on. And I can even say, for instance, let's say, what is my second favorite fruit? So we can say element 0 so that we get access to this list. And then here we need element 1 for second favorite fruit. So we would say like this. And this would print cherry, as you can see. Now, what do you think would be printed if I say 2, 0, for instance, in this case? Yeah, Anna is correct. So now let's explain why. So 2 means that here, right, this is element 0, element 1, element 2. So we would go into Gio's favorite fruits. And inside this list, we would say which is the 0th element, which is kiwi. So when we run this, we will get kiwi. So this is the idea of lists between lists. And also, to be clear, there is no limit to how deep this can go. Like you can have a list of lists of lists of lists and so on. Like there is no control on this. I mean, there is in the sense that after a point, your computer won't be able to hold so much data and your program will crash, depending on how much RAM you have. Like let's briefly cover that actually. So the integer numbers here, for instance, each value takes, I believe, 4 or 8 bytes of memory. And similarly with strings, each character is usually 1 byte of memory. So the bigger text you have, the more memory it takes. And eventually, if you have enough variables created with maybe because of loops that we'll cover, recursions and such, we'll cover what that is. But basically, if you create and allocate enough variables, there won't be a room in your computer's RAM anymore, and eventually your program will crash. This is called the Stack Overflow exception. And yeah, it's possible to get an upper limit. But like this, we can have a list of lists of lists and so on. Like let's say list of list of list of numbers could look something like, yeah, like this, for instance. Like this is a list of numbers, a list of numbers, and a list of numbers. If I print this to the screen, it prints directly in a line. But if I just say firsts, seconds, first, yeah, it gives 6. Yeah, Copilot auto completes the code. Let's rejoin once this meeting finishes, and then we'll cover tuples and dictionaries as well, because sometimes it's not best to store every listing in a list. There are other ways to store collections of objects, and we'll cover that in our next lecture after this one ends. All right. Feel free to ask me any questions. And we'll get into tuples and dictionaries right after this. Let me see if I missed anything for lists. So, as I was saying, we went through a couple examples of lists of lists of lists and whatever, any level of depth. Lists of strings, list of booleans, of integers, of whatever. List of strings, could be anything. Now let's just cover one more thing, which is how indexes can be used in iterating. Like, let's say we have two lists and we need to compare two lists of same size, and for elements at the same place, let's say we have to compare which one is bigger each time. So here's what I mean. Let's say we have two teams competing, team one, and they have scores in some 5 games. So team one scores will be maybe 10, 5, 8, 15, 2. And team two scores, wait, team one system is that? Are maybe 7, 4, 10, 12, 15. And so maybe I want to know how many times team one won and how many times team two won. So let's say team one wins are 0 at first. And I want to somehow go through each index. So this is index 0, index 1, index 2, index 3, index 4, and just compare which one wins on that index. So let's say team 1 wins, team 2 wins, and draws. So yeah, you get the idea. So we would have to iterate over not the elements themselves, but through the indexes. So to be clear, these are the indexes of 0, 1, 2, 3, 4. And we can always get the index at specific place by saying team 1 scores at 0, or like team 2 scores at 0, and then just comparing them. So I'm going to use that with a list. So here's what we can do. We can find out what their size is by just saying len team 1 scores. I could also say len team 2 scores, but they're the same size, so it's the same thing. And then we want to go through each number from 0 to that size. So that size is 5, so it will be from 0 including 4. For that I say for I in range size. So range size basically gives a list that is 0, 1, 2, 3, 4. So each time we would say team 1 score here is just team 1 score set I, and team 2 score here is just team 2 scores at I, because for both of them it's index 0, 1, and so on. Each time we will say if team 1 score is more, then team 1 wins increases by 1. Else, if team 2 score is more, then team 2's wins go up by 1, and otherwise the draws go up by 1. And then in the end, we'll say this is how many times each of them won and how many times we got a draw. So for instance, for this case, we see that 3 times team 1 won, 2 times team 2 won, and there were no draws because they never got the same score in the same round. So like here you can see, yeah, this one team 1 wins. In fact, let's say each time who wins. Team 1 wins match. We say I plus 1 because this I counts from 0. But we don't want to say match 0, we want to say match 1. So let's say team 1 wins this time, team 2 wins this time. And let's say match I plus 1 is a draw. In fact, let's add 1 artificially so that they have a draw at least once. At index 5. Let's see what our code does. So you can see that team 1 wins match 1 and match 2. Team 2 wins match 3, team 1 wins match 4, team 2 wins match 5, and match 6 is a draw. And so we have 3 wins from him, 2 wins from that, and 1 win. And how did we do this? Basically, we just iterated over the possible indexes and put them in I. So size is 6, so range size just gives basically a list that is these numbers. And for each index, we take both values and compare them. That's the idea. All right. Let me see if I'm missing something in the chat. Difference between enumerate and range. Okay. So Anna asked us what's the difference between enumerate and range, and the difference is because of this, I was only getting the index, and then I had to get the element myself. With enumerate, like we have an example right here. Let me show you. That is done for us, basically. Here's what I mean. So if I did this with enumerate instead of range, here's what I would get. So you see this code. Instead, we could say for I, and let's say team1 score only in case there's a list of only one thing that we care about. We can say in enumerate team1 scores directly. We could also say like this. So pretty much everything would be same. The only difference really would be that this time, because we wrote enumerate and directly on the list, instead of taking the length of the list and putting range over that length and then taking the element, instead we get both the index and the value that which we took right here, right from the index. So basically enumerate already takes the value at that index as well. So the difference is if we go directly, we only get the score itself. If we go by index, we can say in range len team1 scores. And then we would have to get the thing ourselves by saying team1 score equals team1 score set I. Or alternatively, we can say enumerate, in which case we get both the index and the value at the same time. That's the only difference. Is it clear, Anna? We'll have examples in our examples.py as well that I'll send. Okay, just for a moment, take another look at it, everyone, as well. I have an emergency. I'll be back in exactly a moment. But yeah, take a look at this and tell me what you think. Right, so are there any questions about this? Essentially, the difference between yeah, I can. Okay, so Anna asked what's the difference between range of team scores and range of lengths of team scores. So let's do that as well. Let's comment this out. Let's come down here. Now let's just do that. So what would happen if I say for some x in range teams1 scores in print x? What would this do? Let's see. It will not do anything. Range works on a number. So range wants a number, like let's say 10, in which case it will give us all the numbers from 0 to 9. So if we want to go through the elements themselves, we'll just say for x in team1 scores, in which case we would just comment this out. In that case, we would directly just get the scores that the first team got. But if we also want the indexes, we could also say for I in range length of T1 scores, in which case we would get the indexes from 0 to 1 and so on, and we would say score at index I is, and this thing. So like score at index 0 is 10, score at index 1 is 5, and so on. And the equivalent of this is for I score in enumerate T1 scores. And then, yeah. So this is the 3 ways to go through a list, basically. One is to directly go through values, another is to take indexes and then take the value with the index, or just ask for index value pairs. Is this clear? Just add this to our examples as well. Right there. One moment. All right, I'm back. Apologies for my delay. Now, does everyone understand this difference between these 3 kinds of for loops?
Yes, I do.
Okay, good. We'll have some homeworks about this, so it's fine to have some confusions, but yeah. Now, I want to move on to tuples. So basically, the lists that we covered so far are one kind of collections. So essentially, there are many ways to create a collection of values, and list is one such kind, which is most useful when we want to be able to just always add new elements, remove elements, have a structured order so that the 3rd index is always this value, 5th index is always that value. and do things with them. But sometimes we can make some sometimes we can make some optimizations. For instance, if we know that we don't care about order, we might use sets, which we'll cover in a bit. For instance, if we know that we want to have key value pairs like index and then what comes at that index, we would use maybe dictionaries. And if we want to have just a static list, which will never change values, will never add elements or remove elements, we will use tuples. And so right now we'll cover tuples. So essentially, tuples are a limited case of a list. So everything a tuple can do, a list can also do, but tuple cannot change elements and so on, which makes them more efficient at some tasks, but at the cost of having less capabilities. Right, so let's go through examples of what a tuple is and how it's different from a list. So right now, for instance, we can think of tuple as when we're really describing one value which just happens to be made of multiple parts. For instance, coordinates. So a coordinate in, let's say, 3D space would have X, Y, and Z parts, right? So for instance, let's say that some neuron is located at X 10.5, Y 3.2, and Z of minus 4.1. We say that these are the coordinates. We could have just as easily said that this is a list and everything would work just fine. List, tuple, same thing. But because this is a tuple, we will not be able to change values. Like basically that's the difference. And we want tuples because if we know that the values won't change, we can make some optimizations with them. We can also be more certain about their behavior. We can be certain that it will always have this size. And yeah, basically, when we know that it's not going to change, it's useful. So that's the idea with tuples. Pretty much the only difference is that we write them with round things. Right, so a tuple is just a limited case of a list, which, unlike the list, cannot change the elements after it's been declared. So whatever it is set at the time of creation and it stays that way. We can convert between lists and tuples, but once it is a tuple, it doesn't change. That's the idea. So for instance, if we were to uncomment this line, this will crash. So let's say here you can see tuple object does not support item assignment is the error we get. So we can't change the values in a tuple. It's good when we for sure know that we don't want to change something. And also, yeah, unpacking is a useful trick we can do with it. Let's actually spend a moment to understand unpacking. So suppose that for a bunch of people, like let's take a more complicated case. Let's say we have student data, right? Which is a list of tuples in this case. So here's what we would say. Let's say that for each student, maybe we have name, age, and performance. Let's say A, why not? Let's say that we also have, yeah, that's fine. Let's get a couple of those. And now we can unpack this like this. We can say for name, age, and grade in student data. And the reason why we can do it directly like this, let me just delete it. The reason why we can directly iterate over them like this is because really this is what's going on. So in fact, we could change this with just student. And we can also say like name, age, grade equals student. So essentially, whatever we have in a tuple can be deconstructed such that each of the parts become separate variables. And this is just the equivalent to writing it like this. And this is equivalent to writing it like this. So this is something useful that tuples allow us. Now, to be clear, if I changed this to lists instead of tuples, to this, actually, this still works. I believe this is a Python update. Okay, yeah, actually, yeah, list destructuring also works because it would perceive it like this. Yeah. So both lists and tuples actually, yeah, allow us to destructure data like that. Let's take an example again. Let's say we have ages of some people. I can say age 1, age 2, age 3, and 7 are equal to ages, and that way we can then print just age 3, for instance. So we can go back and forth between lists and actual list of individual elements. That's the idea with destructuring. Another reason why destructuring can be useful is because maybe we don't care about some of them, but we care about some others. So let's say I have a student data about just one student, which says maybe name, last name, age, no, some score, some date that actually doesn't mean anything. And maybe we now want to destructure it, but such that we only want the first name and the last name. Or maybe we don't care about last name, so you can say like this. And we want age, and we don't care about the rest. So in places where we don't care, it's common convention to use this, because this is actually a valid variable name, just the underscore, and it's something that we won't use. So if I do it like this, I still have the first name and the age. The only thing that changes is that we didn't care about those fields, so we ignored them, and we just extracted the ones we cared about. These are the main ideas of what a tuple is for. It's basically a limited form of list, essentially. All right, at this point, are there any questions? Let me see. No, that's an old one. Okay, are there any new questions right now? Okay, Anna doesn't have a new question. Does anyone have a new question?
No questions.
All right, that's good. Okay, then. This is pretty much it for.
No, thank you.
Okay, let's then move on to next thing. And we have some examples here, like measurement is a tuple, and then we extract the values from it and such. So when you see multiple comma separated values and then equals and something, that means that this one side is a list or a tuple, and it's been destructured, such that first element goes here, second goes here, and so on. All right, now we get to something more useful than tuples, let's say. Useful in the sense that it gives us a new capability. And this is a dictionary. So let's see what that looks like. So until now, in a list, basically each element corresponded to some index, right? So for instance, in our list of numbers, or list of names, even let's say names, whatever, each one is at a given index, right? So if I ask what's at names 1, I get Bob and so on. But what happens when we have a kind of data where the correlation is not between a number and a name, but between, let's say, a string and a name, or a string and something. So let's say, for example, that I have many students, and I want to know Nika's student data or Gio's student data. For situations like that, it might be more useful to be able to say, like, let's say we have a bunch of student data here. Like one is 22 likes clothing, whatever. And another is maybe, yeah, let's just say a bunch of people like that. It would be very useful if instead of just element at 1, let's call it data actually. if we could just say instead like Liam and somehow get Liam's data. But if I do it like this, we crash because list has to take integers, it can't just take a name. This is where dictionaries come in. And here's what dictionary would do for this. A dictionary would say data equals, then for Nika, it would create a value. For Maria, it would create a value, and so on. But in fact, let's say for Nika, it would create this value. So now, because dictionary writes it like this, in a list, it's kind of implied that this is index 0, this is index 1, index 2, and index 3, right? But in a dictionary, this is not the case. In a dictionary, we have like this. So now I can just query them by name. Like I can say, what's Nika's data? And I would get just 22 likes coding. I could ask, what's Sophia's data? And I would get 20 last painting. Now, what happens? Now, this is a different kind of collection from list because, again, it doesn't use numbers as indexes. Instead, it uses strings as indexes. That's the idea. Now, let's see what would happen if I just iterated over them. What would be printed on the screen? Let's see. You can see that if I go through data, I get just the keys. So this is the equivalent to for I in range len that we did before, which gave us just the indexes. So this is actually key, pretty much. And then I can say data of key is, and then data at this key, right? And this would give us data of Nika is this, data of Maria is this, and so on. Now, there's a couple of ways to use dictionaries, and I will quickly go through them. So right now you can see basically the structure is that we have strings as keys and a tuple of something as the values. So we could alternatively say for name and personal data in data.items. And yeah, basically we can also then deconstruct this and so on. In fact, let's just say in the interest of and then just personal data. Let's see what this has data of. Let's see what this would give us, just for a second. So data.items will give us a list of pairs such that for each pair we have the key and the value. So in this case, we will have the name and the personal data. Name being this and personal data being this. So in this case, Nika has data of this, Maria has data of this, and so on. So in fact, I can literally just print this back. So the difference is this. So data at key is equivalent to personal data if we say data.items. These two are equivalent. And in fact, let's say another one. X and data.items. If I print X, what would this give me? This gives a pair. Let's comment these ones out for a second. This would give us just the name and the value, the key and the value, and so on. So these are the different kinds of ways to read into these. Let's just stick with this way for now, for simplicity. And it's just going to give us this. Data of Nika is 22 likes coding, data of Maria is 21 recycling, and so on. And dictionaries, like lists, can be manipulated. They don't really have specific indexes, so it doesn't make sense to say insert at this location because you are given custom index for everyone anyway. But here's how you could add a data to a dictionary. You could say data at, let's say, some new name like Alex, and just equals whatever, new thing that we want, 35, maybe enjoys chess. And now, if I print all of data, you can see Alex is here, right? So like if I print data at Alex, you can see there it is, 35 enjoys chess. We could also change values. So I could say data at Nika now equals this instead. So now we can see that Nika's values became this. So we can make changes inside this list. We can change what value we store at each element. And we can also add new elements or even remove elements. So here's how we would remove an element. So we would say data. Am I remembering this correctly? I remember. Yeah, there we go. I just need a moment to remember the syntax. By the way, it's completely normal to always be Googling or looking up the syntax. You don't have to bother too much with memorizing it. You just need to understand the ideas. So previously in a list, we could say remove a given value or remove at a given element. In a dictionary, we can say remove for a given key. Like let's say I want to remove Liam, I would say del, which stands for delete, and then data at Liam. And that would, let's just print data side by side to be clear. So yeah, basically Liam is missing. In fact, to make it more clear, let's only print the keys. So we can say data.keys, and this will only give us the names of the people we have. So it used to be, it gives dictionary keys, which is Nika, Maria, Liam, Sofia, but now it's Nika, Maria, Sofia. So yeah, we can change an element, we can add a new one. Let's add one right here anyways. And yeah, that's the idea. We can add, remove, change, and everything that we could do in lists. The only difference being that now our keys can be text instead of numbers. And just like before, we can say, we can ask, is this element in the list? So we can say, Nika is included, is some Boolean variable, and it says Nika in data. Is Nika included? Yes, Nika is included. But what about, let's just say someone is included. Let's say we ask about Liam, because we know that Liam is not included. Then we'll get false, because Liam is no longer included. So the idea is by asking element in data, what we're really asking is, this list of keys, does it include this value? That's the idea. And then we can, yeah, go through the keys, go through values. And so basically a list, but instead of numbers, it can use text as indexes. All right. Is this clear? And we will have some homeworks about this, so it's no worries if you don't remember the syntax, just the idea itself.
It definitely is.
Okay, good. Let me see what else we had here that I didn't cover. So we covered this, so that we can assign some, yeah, basically value at a given index, but index is not text. We can ask, is this element in a list? Or we can also ask, is this element not in list? So not in is, well, the opposite of in. I mean, you get the idea. This will only be true if it's not included, otherwise it will be false. And yeah, we can say if it's not in there, do something else. If it's in there, do something else. We can say dot items, which will give us a list of pairs of keys and values. Or we can say dot keys, which just gives us a list of keys, and so on. Get the idea. We can also say dot values, which gives us only the list of values. So let's quickly show that as well. print data.values. In this case, we get just this without the keys. You get the idea. Okay, that's it for lists, and let's just very quickly cover sets. So again, we had lists normally, which were just a collection of elements. They can be duplicated, so like we can have multiple instances of one element. They have an order, so there's first, second, third, and so on elements. And we can add to them, we can change them, we can remove from them. That's a list. Everything same, but we cannot modify the data. We can't add, change, or remove is called a tuple. Everything same as list, but indexes can be strings instead of numbers is called a dictionary. And now there is one more case, which is set. A set is basically just a list where every element is unique. That's it. So for instance, right here, we can see that we have a list of neurotransmitters, but some of them are clearly same, right? Like we are repeating this value twice, we are repeating this value twice. I'm sorry, this value 3 times. Now, if we make this into a set, only one of each will be kept. In fact, let me just copy this over here so we can see it. So right here, when they were a list, there was duplication, but after we turn it to a set, it's no longer duplicated. And basically checking if an element is in a set is a little bit faster for sets than for lists. So it's used for efficiency. And yeah, set makes sure that the elements stay unique. So that's the idea. It's a limited case of a list, which makes sure that the elements are unique. And it's a bit faster for getting a specific element or for checking if an element is in the set or not. So that's the idea of a set. We create it by saying set, and then inside it given a list or a tuple, and it will be converted into a set. Okay, that's pretty much it.